Hello everyone! Right, okay, so I'm looking over a real life example of graphs. I'm going to do two examples of possible questions you could be asked in your exams on real life graphs. So the first example I'm going to be looking at is a height and time graph. So this graph right here, the height h of a tennis ball thrown in the air is given by the formula h of t is equal to 10t minus t squared, which is graphed below. And we see here t is just time in seconds. So my input is time in seconds, and my output is the height at which the tennis ball is. So this is a question that you would be doing if you go on to applied maths and leaving cert, but this is a very more simplified version for the junior cycle exam. So basically what's happening here is a little tennis ball is being thrown in the air, and after 5 seconds I'll be able to calculate what the height would be. So let's see what question they asked here. So it was modeled with this function here, 10t minus t squared. So use the graph to estimate answers to each of the following. What is the height of the tennis ball after 2.5 seconds? So if we're lucky here, I go to 2.5 seconds on my x-axis. So t is my input in this case, so time is my input. So after 2.5 seconds, I go to 2.5 here. On my x-axis, I go up. Ding. And when it meets here, go over and check. So that is roughly going to be, so after 2.5 seconds, the height of the ball, h, is roughly going to be 19 meters. Right, make sure to put your units in. So after 2.5 seconds, that tennis ball is 19 meters in the air. At what time is the height of the tennis ball 12 meters above the ground? So again, this time I'm looking when the ball is 12 meters above the ground. So I go up to where my height is 12. I draw a line across and I find where it intersects here. So I draw down. Go over here. And draw down. So I see here, after 1.4 seconds, the ball is 12 meters in the air, and here at around 8.6 seconds, the ball is 12 meters in the air. So I don't know if the yellow, you can see it perfectly there, sorry. So after 1.4 and 8.6 seconds, my ball is 12 meters in the air. So this makes sense. Just look at the trajectory of the ball. So the ball's going up, 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 up. It then kind of reaches a point. Like, gravity is a thing, ladies and gentlemen. So the ball just doesn't keep going up, up in the air. It has to fall back down eventually as well. So the ball goes up. It passes 12 meters. It goes high, it goes up, 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 up. Goes to around 27 or 25. Then it has to come back down, and then it's going to reach 12 meters again on the way back down. So that's why we have two times for it. So at what time is the ball 12 meters above ground? So it is 1.4 and 8.6 seconds. Then what is the maximum height of the tennis ball? Again, use my graph. So remember, my y-axis is my height. So my biggest y value is at the apex here, this point here. So maximum height happens at 5 seconds, and then I read the point here, and my height is going to be 25 meters. So the maximum height of my ball is 25 meters. And that's an example of a time height graph, or a real life example of a quadratic graph. So it would be the parabolic shape an object would make if you throw it. Then example of a real life application of a linear graph would be comparing prices of two companies, right? So for example, this one here, this is a past examination question. So two mobile phone companies, Cellulon and Mobile, offer price plans for mobile internet access. A formula in X for the total cost per month for each company is shown in the table below. X is a number of megabytes of data downloaded per month. So Cellulon, they cost 4 X. So for every megabyte you use, in cents, by the way, so it says here the price is in cents. So it costs you here 4 cents for every megabyte you use. X is the number of megabytes you use. So it'd be 4x. So it'd be 4 times the amount of megabytes cents you use. But mobile here, they do 1,000 plus 2x. So it's 1,000 cents plus 2 cents for every megabyte you use. So now let's plot these out first. So as I said, I'm pulling a little Ina Garden. Here's a graph I prepared earlier, ladies and gentlemen. Right, so here's a graph of mobile and Cellulon. So the purple graph here is Cellulon and the blue graph is mobile. So if you want to know how to graph a function, watch like 2 videos ago. I'll show you how to do it. So let's read the questions they ask us here. So they want us to know here, which company charges no fixed fee? Justify your answer to the relevant formula or graph. So they want to know which company doesn't charge a fixed fee. So we have to kind of know what a fixed fee is first of all. So a fixed fee would be a fee a company charges before they do a job. So for example, let's think of a taxi. So in a taxi, it's kind of standard practice is you pay for the distance you traveled. Fair enough. But there's a fixed fee for every person that's in the taxi. So you might charge, I don't know, like €3 a kilometer. I think that would be very cheap for a taxi. But anyway, say a taxi man charges €3 per kilometer, but for every person that's in the taxi, that's an extra fiver added on the total. So if I was just traveling 2 kilometers home, right, and it was just me, it would cost me €11. But then if I was with another friend, that's another person, that's another fixed fee on top. So it'd be actually €16. So a fixed fee is just a price paid before the actual job or thing gets done. So if we look at here, so we have to look at 0, yeah? So fixed fees usually, here's a little hint, fixed fees are usually the y-intercept, yeah? So if we look at y is 0 here, right? So when I've used 0 megabytes of data, Cellulon charges me none. When I use 0 megabytes of data, mobile have already charged me 1,000 cents or €10. So they've already charged me €1,000, but I haven't even used any data yet. So that is known as a fixed fee. So a fixed fee happens before like a job has been done. So which company charges no fixed fee? Justify your answer. So the answer here is going to be Cellulon. Right, Cellulon. Because they charge €0 for 0 megabytes. So they have no fixed fee because their y-intercept equals 0. Write down the point of intersection of the two graphs. So the point of intersection remember point of intersection is where two graphs cross each other. So they cross at this point here. So what does this mean? So they cross at 500 and 2000. So that means for 500 megabytes of data, they both charge 2,000 cents or €20. So they're both equal, or they both cost the same amount when you use 500 megabytes of data. So Fergus wants to buy a mobile phone from one of these two companies and wants his mobile internet bill to be as low as possible. So explain how your answer to part C would help Fergus choose between Cellulon and mobile. So Fergus wants to buy a new mobile phone and he wants to know which company to go for. Now, these companies, one company is better than the other under certain conditions. So if we see here, Cellulon, yeah, if he uses less than 500 megabytes of data, he's actually going to be paying less with Cellulon as he would with mobile because the Cellulon is less than mobile. Like from here, Cellulon is less than. Like it's beneath mobile. So if he uses less than 500 megabytes of data a month, he's better off going with Cellulon. But, however, If he thinks he's going to use more than 500 megabytes of data, if we look at my graph here, well, then he's probably better off going with mobile, because mobile is now the lowest, um, is lower than Celeron after 500 megabytes. So what you'd say for that one is, by looking at the graph, if Fergus plans on using less than 500 megabytes of data a month, he should go with Celeron, as the Celeron is below mobile from when X is greater than 0 and less than 500. If Fergus is going to use more than 500 megabytes of data, he should go with mobile, as they charge less than Celeron when X is greater than 500. So again, just a little test here. If he uses 600 megabytes of data, ding, 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 mobile is only going to cost him, if he uses 600 megabytes now, mobile is only going to charge him like 2,250. So €22.50. But if I did that now for Celeron, if I had it for Celeron now, they are going to charge around 2,450, so €24.50. So Celeron will be more expensive than mobile if he uses more than 500 megabytes a month. So that's a question you're going to have to interpret and answer yourself. So yeah, so Fergus was using less than 500. Celeron, if he uses more than 500, you better off going on mobile. Right, and that's example of two kind of exam questions you would be asked on real life applications of a graph. And so yeah, I hope this helped. See you later. Peace.